Hi guys, today's notes are on 9.1b, special right triangles and finding sides and angles using those special right triangles. So I'm sorry I marked on this already, but I'm going to just go over what I'm doing. So the angles of 30, 45, and 60 occur frequently in trig and come from special right triangles. And once we find the special angles of the special angle trig values, you can memorize them and use them to find unknown side lengths in special triangles. So we use a unit triangle to start, and a unit triangle comes from a unit circle. Assume the radius of this circle is 1. Okay, so that means anywhere from the center to the edge, right, all of these lengths are 1. Well, if I then take this point and go straight down and create a right triangle, I can pop that out, and that's what I have right here so far. Okay, so this is a 30, 60, 90 triangle. It is specially drawn for this. Okay, so now let's imagine I take this triangle and reflect it over, sort of like this. And do you guys see how that now this triangle is an equilateral triangle? Because these are both 60, so then this whole angle here is 60. Well, if I know the radius is 1 from here to here, that means the hypotenuse of every triangle is 1. And so that means if that side length is 1, this whole thing is 1. But I don't want to focus on the whole thing, even though this is 1 as well. I want to focus now on this red triangle. Well, if this whole thing is 1, then this side length here must be 1/2, correct? And once I have two side lengths, then I can use the Pythagorean theorem, x squared plus 1/2 squared equals to 1 squared, to solve for x, which is our last side. So now I have x squared plus 1 over 4 equals to 1. Subtract a fourth on both sides. We take the square root of that, which is square root of 3 over 4, which is just root 3 over 2, because it's the square root of 3 over square root of 4. Okay? So anytime you see something like this, we know that one of the sides, the hypotenuse is 1 always, notice. This short side is 1/2, because we can imagine the triangle being drawn in. And then this one is root 3 over 2. Okay, the second kind of triangle is this one in here, the second line. And this triangle is what we call a 45, 45, 90 triangle. And so this triangle has a hypotenuse of 1 as well, but we know that since the angles are the same, then the side lengths opposite those angles must also be the same. That's our geometry rule from last year. Okay? So that's why I labeled it as x and x. So when I solve for the Pythagorean theorem, I can do x squared plus x squared equal to hypotenuse squared, which is just 2x squared equals to 1. Divide by 2. X squared equals to 1/2. X equals to the square root of 1 over square root of 2, which is 1 over root 2. Well, we don't want a radical on the denominator, so we got to keep going and rationalize, which gives us a final answer of root 2 over 2. And so I can fill that in here as both side lengths. And then if you take a moment and notice that a 30, 60, 90 triangle is the same as a 60, 30, 90 triangle, then we know that this is 1/2 and this is root 3 over 2, right? It's the same triangle, just flipped. Okay, so let's take a moment and sort of establish, like, how can I expect you to remember these triangles without doing Pythagorean theorem ever again, unless you really just forget? So how I remember is that we can figure out the hypotenuse always, and this short side should be memorizable. Okay, so it's really these two numbers you have to memorize. The square root 2 over 2 comes from the two sides that are the same, and the square root 3 you can think of as like I have 3 different sides that are the same, or that are not the same, right? So that's why there's a 3. Okay, so now let's take a moment and we're going to do sine, cosine, tangent for 30, 45, 60, and do cosecant, secant, and cotangent. So sine. So, TOA. This is going to be 1 over sine, 1 over cosine, and 1 over tangent, just as a review. Okay. So, opposite over adjacent. Now, I've drawn this out really nicely for you guys for each triangle. You guys see 30, 45, and 60. So now you can label these as opposite, hypotenuse, and adjacent. So, opposite over hypotenuse is 1/2 over 1, which is just 1/2, right? I can do that for all of these. So really, it's just opposite. So this will be root 2 over 2, right? And this one is root 3 over 2. Okay, so now I'm going to just go across for each triangle. Cosine is adjacent over hypotenuse, which is over 1, so I can just write root 3 over 2. Tangent is opposite over adjacent. Okay, so here's where we run into problems. If you have a double fraction like this and the denominators are the same, you can cross them out. We have 1 over root 3. We don't want that though, because we don't want a radical in the denominator. So we're going to times by root 3 and root 3 to give root 3 over 3. Okay. Cosecant is the reciprocal of 1/2, which is just 2. 2 over root 3 is a problem, but we're going to multiply by root 3 and root 3. So it'll be 2 root 3 over 3. Because root 3 times root 3 is square root of 9, which is just 3. Cotangent, I'm not going to flip my final answer for tangent. I'm going to go here, and 1 over root 3 reciprocals to just root 3. Well, if that's the case, we can go through and fill out the rest of these, right? Cosine is adjacent over 1, so this is the same. Tangent is opposite over adjacent. This over this is just 1, because it's the same. And then I'm going to take the reciprocal of this, right? 2 over root 2. So I'll be 2 root 2 divided by 2, which is just root 2. That means this one's root 2 also, right? Because it's the same thing, but reciprocal. And then this one will be 1. Okay, what happens here is that these values switch, because now I have adjacent over hypotenuse. And the reciprocal of this was 2, and the reciprocal of this one, do I have it here? No, I don't. Oh, I do, right here. Cosine and secant, so I don't have to do all that work again. Right, you see how these just switch? And then this one is going to be opposite over adjacent, which is root 3 over 1/2. Cross out the 2's because they're the same denominator, so I have root 3. Oh, and that looks familiar. So I know the inverse is, or sorry, the reciprocal is root 3 over 3. Okay. Right now it's a pretty big pain to fill all this in. So we'll be talking about how we can have these memorized and do a little bit better. Okay. Let's move this down a little. Let's keep going. Ooh. Okay, so what's the purpose of doing all this? Well, there's so many ways that you can actually solve triangles. So what you could do is, because this is a 30, 60, 90 triangle, you could draw a triangle on the side and say, well, I know this is 1, this is 1/2, and this is root 3 over 2. And you can say from 1 to 16, I multiply by 16, so I multiply this by 16. That's one way. Another way is we could write some ratios and do 16 over x is the same as 1 over root 3 over 2, right? And solve for x. But another way that I forgot to mention in class, and the one that I actually want to focus on, is we can use 30 degrees to write a trig ratio. So 30, this is opposite, which we don't have, but we have adjacent and hypotenuse. So if I use SOHCAHTOA, I have adjacent and hypotenuse. So I can say, well, the cosine of 30 degrees equals to x over 16. And this is where that table that we just filled in comes into play. Cosine of 30 is square root 3 over 2. So I can say square root 3 over 2 equals to x over 16. And we can cross multiply and solve. So that gives me 2x equals 16 root 3. Divide by 2 on both sides, and we get x equals 8 root 3. In class, someone asked, like, well, if I know 20 is one of the sides and it's a 45 degree, could I say this side is also 20 and use Pythagorean theorem? Absolutely. Okay. Another thing you could do is say that I have opposite over hypotenuse, right? So that's sine of 45 degrees equals to 20 over x. Okay, so I know this is more complex right now than Pythagorean theorem, but I'm just showing you a different way of doing things. And so we can go back, find sine. Ooh, that's a complicated looking one, right? It's okay, we can still do it. Square root 2 over 2 equals to 20 over x. Can we cross multiply? Yes. And we get x times root 2 equals to 40. Divide by root 2 on both sides, which equals to 40 root 2 over 2. And so that equals 20 root 2. Remember, if the numbers are outside the radical, you can always simplify them. Okay? So now let's move on. Sorry about that. And we are going to be doing something called solving the triangle. And so solving the triangle, you need a calculator for if it's not a special right triangle. This means we're going to have decimal values usually. But you need to find all the unknown side lengths and all the unknown angle measures. And that's called solving a triangle, basically filling everything in. So let's tackle angles first because I have 2 of them and I know that the angle measure of a triangle should total to 180. So I know 28 degrees plus b for angle B plus 90, right? So that's A plus B plus C equals 180 degrees, equals to 180. And I'm showing more work than I need to, but really what you're doing on your calculator is 180 minus 28 minus 90, and that means B equals to 62 degrees. So we can write that in. Well, I don't even need to write that in. Let's just box it. Okay, so then once we move forward, we can't use the special right triangles anymore, right? So we don't have a second triangle to compare to and multiply quickly. We don't have 2 sides, so we can't use a Pythagorean theorem. And this is where we have to use this method that I showed you guys here. So I know that I'm going to use, well, I'm always going to start with the beginning, because what if I messed up on 62? I don't want all my answers moving forward to be wrong. So I'm going to start with 28, and I'll do opposite first. Oops, so sorry. Okay, so I'll do opposite. This is hypotenuse and adjacent. You can only have one unknown. So if I'm going to use opposite as my unknown, then I need to tackle adjacent as my other known. And that's SOHCAHTOA. Right? So that, to solve for A, we're going to use this one. So that means I know that cosine of 28 degrees equals to opposite. Oh, wow, what am I doing? Not cosine, tangent. Sorry, it's a fail. Opposite over adjacent is clearly tangent of 28. Okay, equals to A over 15. Well, how do we solve for A? To get A by itself, times 15 on both sides. And so you get A equals 15 tangent 28 degrees. Okay, so the first thing I want you to do is turn on your graphing calculator. And you need to make sure that you're in degrees, which doesn't always happen because a lot of people don't use degrees all the time. We're going to be switching back and forth, but we have degrees here. So go to mode, A lot of you guys might be on radians, but scroll over to degree, hit enter, and then quit, get back to your main screen with second quit. Okay. So now we are going to just type in 15 tangent, here's your sine, cosine, tangent, 28. You don't need to type degrees because we've already established that it's degrees. And that gives me 7.98. I didn't say what to round to, okay? I will specify elsewhere. Well, I have A, I have B, now I need to find C, right? So if I now want to use the hypotenuse, I could use adjacent or opposite, but I want to use adjacent. Always go back to what you're given. So now I'm going to use adjacent and hypotenuse. That's cosine now. Okay. So now I will do cosine of 28 degrees equals to adjacent is 15 over C. We can cross multiply. And we get C times cosine 28 equals to 15. Divide by cosine 28 on both sides. I don't need to see this red work, but I need to see the blue work. And I get C equals 15 over cosine 28. That'll be 16.99. I accidentally copied this one over and I didn't mean to put the triangle in there with all the measurements. I think what I wanted to do was take out the 28, take out 15. And if I give you this triangle, when you place things in there, just make sure if you aren't given the triangle that angle C is always opposite, right, side C. So angle A here and angle here. So you should be able to do this on your own if you wanted to try it, okay? So I would say for right now, I absolutely want you guys to try these two on your own. If you want to try 2 and 3, you can also try 2 and 3.